Okay, next bit. This is alcohol. This thing is what you call an ester. The ester bond is basically, that is the bond. That is the new bond formed by forming ester is condensation. Condensation because you minus the H2O, right? So that is the C double bond O OH, and then there is the OH there. So that is your but you gotta identify which one of these is X. X is the one with 2 carbon, you see, 1, 2. Here you have 1, 2 carbon. Here you only have 1 carbon, so it cannot be this, yeah. So X must be CH3 C double bond O OH. All right. So if that is true, so if that is CH3 C double bond O OH, that is a carboxylic acid. Alcohol to carboxylic acid is a oxidation. All right, and I'm sure you will know that common oxidizing agents in chemistry includes, you need acid, okay, you also need Cr2O7 2 minus, okay, or you can use the other one which is also in your syllabus, is manganate 7. This is called, they don't say name, they say identify. So you can give formula or you can give the name. If you give the name, you've got to have acidified dichromate bracket Vi, that's for 6. If you give the name, you've got to have acidified manganate 7 VII. Okay, I prefer the formula, okay, it's so much easier. You just write the correct formula, provided you know the correct formula, which you should do because these two are common oxidizing agent given in the redox topic, yeah, that you will have learned. So after I finish this paper, there's something I found out from your new updated O-level syllabus. It seems like they are no longer accepting these. This is actually technically what we use in A-level, and this is technically correct, okay? I don't believe you will be penalized if you do this, if you write this down, because it is correct chemistry, definitely, okay? However, in O-level, they have said that this is carcinogenic, it can cause cancer, so they have removed this entirely from your paper 3. So they remove it from paper 3. They also remove it from the theory paper as well. So essentially they're looking at using this, which is not carcinogenic, to oxidize all alcohol to carboxylic acid. So if you watch the other video in paper 2.1 of the May June 19, there's a similar question where I say you could use this as well. I stood by my belief. A chemist who will mark your paper would know that it's definitely correct chemistry. They cannot penalize you, provided you get the formula right and you get the acid right. Okay, and if you put this down, you won't be penalized as well. But I guess if you haven't studied this, if you have used this all your life in O-level, you can stick with it. Okay, because both are common oxidizing agent anyway. That's all I can comment on that. All right, so just have a look out on it. I think in the older papers, I think they only removed this from the O-level syllabus not long ago. So I know during my time, when I say during my time, that was a while ago, we still use this in the paper 3 that it was available, and we also have this in the curriculum syllabus back then as well. So both were alternative back then, and just like, I'm sure that both will be accepted as well, but stick with whichever one you have always used, yeah? Okay? Identify the reagent used in step 2. You want to form the ester. So this bit is this bit there, as I mentioned. Okay, there's the carboxylic acid bit from there. The carboxylic acid lose the OH. The alcohol here lose the H from the O. Okay, this is actually called methyl because there's 1 carbon alcohol. Methyl ethanoate because 2 carbon on the ethanoic acid. Yeah. So you need CH3OH. CH3OH. All right. Next question, what's the name of alcohol B? This is 1, 2, 3, 4. So it's a 4-member alcohol. This is butanol. That is how you would know it in O level. Okay. Draw the structure of one other alcohol, isomer of B. So this is a straight chain alcohol. What you can do is instead of 4 carbon, you can have 3 carbon. Okay. You show all the atom and show all the bond. Remember, OH is that, not OH, because you want to show all the bond. 3 carbon, like that. Okay. Why did I draw 3 carbon? Because this is a straight chain. If I have only 3 carbon straight chain, I need to put another carbon somewhere. If I put the carbon here, it's going to be straight chain 4 carbon again. No difference. Instead, what I do is I add a carbon there. Then that is going to give me that. This is a branch because 3 straight chain, 1 CH3 on the branch. If you work out the total number of hydrogen here is 4, 8, 9, 10. Here it will be 3, 4, 5, 6, 7, 8, 9, 10. This is an isomer because same molecular formula, different structural formula. Okay, you can oxidize ethanol, CH3CHOH to CH3 C double bond OH. Have a look at this carbon. It has got 2 hydrogen. Have a look at this carbon. No hydrogen. Loss of hydrogen is essentially oxidation in the context of organic chemistry. So you need an oxidizing agent. So you want to state. So if I were you, I will remember this H plus and Cr2O7 2 minus. So this is typically what you call acidified potassium or sodium dichromate 6. The 6 is very important because it defines the oxidation state of the chromium here, where you have 2 chromium plus 7 minus 2, overall is minus 2. 2 chromium is plus 12, chromium is plus 6. Therefore, you need this if you are writing it in words. Without the acid, it will be wrong because without the acid, there won't be a redox. There's also an alternative you can use, obviously. There is the acidified potassium manganate 7, but I just happen to like the acidified dichromate 6, so both are perfectly acceptable. You could write the dichromate anion because that's the active species oxidizing agent, or you could write K2Cr2O7, or you could use Na2Cr2O7, all of which are equally acceptable. It might not be stated in the marking scheme exactly, but I can tell you as a chemist, it is acceptable and it will oxidize ethanol to ethanoic acid. Okay, ethanol is a simple molecular compound, but why liquid ethanol does not conduct electricity? Simply because this simple molecular compound, all the carbons are used up in bonding. There is no free electrons. We don't talk about ions because this is a simple molecular compound, so you shouldn't be using the wrong terms. Yeah, no free electrons in CH3, CH2OH to conduct electricity. So basically, all the electrons on the carbon are localized because this carbon form 4 bonds. 1 to 3 to 3 hydrogen and 4 to the carbon. This carbon also form 4 bonds. 1 to 3 to the other carbon, 4 to the oxygen. Okay, so all the electrons are not delocalized at all. Next bit, you want to describe, you want to use dot and cross, you want to talk about ethene. If I were you, I would start by drawing the display formula of ethene. So I know the display formula easily. Carbon from 4 bonds, 1, 2, 3, 4. Carbon from 4 bonds, 1, 2, 3, 4. There's no lone pair on the carbon. The hydrogen here has used the only electron it has to form the only covalent bond. Each of these lines refers to one covalent bond. So each of these lines has 2 shared electrons. So if I draw the dot and cross, it will be cross, 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 cross. That represents a double bond, 1, 2. 1 covalent bond, 2 covalent bond. Okay, and then I'll have dot cross hydrogen, dot cross hydrogen, dot cross hydrogen, dot cross hydrogen. What have I done? I have not included inner shell electrons. These are all the outer shell electrons. Carbon is in group 14 or group 4 as you would know it in O level. 1, 2, 3, 4. This carbon, 1, 2, 3, 4. The hydrogen is just one outer shell electrons, okay? Another thing you have noticed is different is I start from the display formula, which I know is correct, and I work from there to there, so much faster. The second thing you notice is in all my dot and cross, I do not draw the shell. I would tell you that it's just my personal preference, but you will see that a lot of marking schemes we have drawn the shell, and then when you go to A level, they don't draw the shell. So whoever is correct, there is no correct or wrong here. It's just personal preference. But if you draw something like this, I would have no objection as an examiner to give you the mark either. I mean, you cannot be penalized if you have shown the covalent bond correctly and you have gotten all the outer shell electrons correctly as well. So this is perfectly fine, yeah?